am Mr. Satish Thalangi, Assistant Professor, Department of Civil Engineering, Walchand Institute of Technology, Solapur. In today's session, we are going to see the program evaluation and review technique for the project management. It is also known as a PERT for the project management. The learning outcome. The students will be able to compare the program evaluation and review technique with the particular CPM network technique of the particular project for the project management. The PERT is also a graphical and a logical representation of the project and its activities. It was developed by the US Navy, and it is used for the new type of projects, or you can say the R&D, or you can say research types of projects. It is an event-oriented network technique. As it is an event-oriented network technique, here particularly it is a deterministic or a probabilistic type of technique. It is represented by the AOA type of network, and in the PERT we usually see the 3 times, of which we use for the finding out the expected time finally. Here in the PERT there is a slack, and with the help of slack we are going to define whether the particular event is a critical one or non-critical one. With the help of this we are going to define the critical path, with the help of critical path we will define the project duration of particular project. Here the particular time estimates in the PERT. The time estimates are the estimates which with the help of the beta distribution curve we are going to define the 3 time estimates. Usually if we consider a single activity, the particular activity can be complete in the prismatic time. It is time, or you can say it is a condition when is here the favorable condition is there, and it is the minimum time required for the completion of particular activity. And the most likely time is a time when the particular condition is a normal one, and it is a normal time required for the completion of the particular activity. And the prismatic time is a time when the particular condition is unfavorable one, and it is a maximum time required for the completion of the particular activity. With the help of all these 3 activities, we are going to define the expected time of the particular each activity, and with the help of this expected time, finally we are going to define the project duration of particular project. Here this is a formula which is used for the defining the particular expected time of each activity, which is equal to a particularly optimistic time plus 4 into most likely time plus prismatic time divided by 6. This is a beta distribution curve, or it is also known as a probability distribution curve. Here it is a particularly prismatic time. This is a most likely time of the particular activity, and this is a prismatic time of the particular activity. Here on the particularly when we see this curve, here the most, or you can say the most expected, you can say the most likely time which is closer to the expected mean time. This is a particularly a beta distribution curve which is used to define the times of each activities. Now expected time estimation of the activities. As we have seen in the earlier slide, the formula which is used to define the expected time of each activity. The activity A, B, C are here. There are the 3 times in the of the particular each activity. That is here. This is 3, 5, 7. This is a 3 is a particularly optimistic time, 5 is the most likely time, and 7 is a prismatic time. With help of these 3 times, we are going to define the particular expected time of each activity. Here, with these are the particularly values or for values of the each activities, that is 5, 8, and 9, which is obtained with the help of the formula of the expected time. After getting this, we are going to calculate the particularly project duration, or you can say the project duration of the particular project. Here the event times. The event times are the particularly when we observe, these are the yellow color box which are representing the event times. In this, the event is first this event capital TE. This is the earliest expected time which is forward move from the left hand side to the right hand side, and the time calculated is from the left hand side to the right hand side. And there are the latest allowable occurrence times, that is which is mentioned below the nodes, that is capital TL, which is calculated from moving from particularly right hand side to the left hand side. Here, as we see the time calculation, 0 plus 5, 5, 5 plus 8, 13, 13 plus 9, 22. Similarly, when we move from the right hand side to the left hand side, 22 minus 9, 13, 13 minus 8, 5, 5 minus 5, 0. This is a particularly event times. Now, this is overall representation of event and the activity time for the network. Here we see all the event time of each event as well as the activity times of each activities. This is a particular network diagram which is representing both the times. As we have seen in the earlier slide, we are going to move from the left hand side to the right hand side for the forward path, and from the particularly right hand side to the left hand side, which is called the backward path. In this particular network diagram, the forward path is represented by the black arrows, and the particular backward path is represented by the red arrows. While moving from the left hand side to the right hand side, we consider the maximum durations for the next activity starting. And similarly, when we move from the right hand side to the left hand side, we consider the minimum times for the activity as late as it's finished. And we move from right hand side to the left hand side for the backward path. This is overall network diagram which is representing the forward path and the backward path. Now, this is a slack of the activity. As we have seen in the CPM, there is a float. In the particular PERT, there is a slack. The slack is a flexible range of the time that an event in a project network can delay without affecting the overall project duration. It is obtained, the value of the slack is obtained by the difference between the latest allowable occurrence time and the earlier expected time. In this network diagram, the yellow box are representing the earliest expected time as well as the latest allowable occurrence times. When we see the difference of the between the particular both the event times, we will get whether that particular activity is having slack 0 or more than 0, on which we can define that the particular event is a critical one or non-critical one. This is slide where we are representing the particularly calculations for the slacks times of each events. Here, when we see the particularly first event, it is 0 minus 0, it is 0. So here the first, as it is starting, it is a critical one. And when we see event 2, here the particularly latest allowable occurrence time is particularly 5, and the earliest expected time is 5. 5 minus 5, again it is 0. So that's why we are representing as a critical event. But when we see the event number 4, where here the 4, when we see the particularly latest allowable occurrence time is 19, but the earlier expected time is 9. 19 minus 9, it is 10, means this particular activity is non-critical, particular event is non-critical one, and it can be delayed as per the value which is obtained by the difference. That is, up till 10 days we can delay particular event. This is overall network diagram, and this red colors are representing the particularly arrows which is a forward path. And when we see the project, particularly project duration is 22 days. This is a table which is representing the events and its particular slacks. The red color events are the critical one, and the black color is a non-critical one. And in today's question, now let's we construct the particular uh, uh, you can say the PERT diagram for the PERT network diagram for the particular problems. These are the three events of each activities. These are the description which are defining the interdependency between the each activities. Now this table is representing the expected time which is obtained by the formula as we have seen earlier. With the help of this particular data, the particular network diagram is constructed. And with the help of this, we are defining each activity's durations, okay, as well as the events slacks. Now, here in this project, the particular critical path one is when we see in the event time 1, 3, and 4, and the project duration is 8 days. Now, this is a comparison between the particular PERT and the CPM. There are 2 to 3 main major points which are the difference between the CPM and the PERT. The PERT is the particularly event orientation type of network diagram, and the CPM is the activity orientation type of network diagram. Here the slack is present in the PERT, and here the float is present in the CPM. Here it is a indeterminate type of technique approach here, and it is a determinist type of technique. Here we define the critical path with the help of the events. Here we define the critical path with the help of the activities. These are the major points in the major points between difference between the particularly PERT and the CPM. Now these are the references for the today's session. Thank you.